So in section 9.5, one of the things we're going to do is solve radical equations. And as part of the process of getting rid of the radicals, you're going to square both sides. Now, let me just show you something about what we're doing in this section and why we're doing it by starting out with a very simple equation, a equals 5. If I squared both sides of this, I would get a squared equals 25. I think we can all agree on that. But now let me move the 25 to the left-hand side and get a squared minus 25 equals 0.
Your audio is messing up again, Professor.
I appreciate that. Let me see if I can't fix something here. So this is a quadratic equation, and one way you can solve it is by factoring. So how do you factor this? Well, that's the difference of squares. So it's a minus 5 times a plus 5. And now is a little trick that we're going to need in solving some of the equations that we're going to work with today. Because you have something times something else equals 0, one of those things have to be 0. Either a minus 5 equals 0 or a plus 5 equals 0. All right, that means either a equals 5 or a equals negative 5. Both of those are solutions. But if you look back, only one of these actually solves the original problem. The other one doesn't. Negative 5 does not equal 5. So that's not a solution. And what that's saying is that, okay, you're not always going to get a solution to your original equation if you square both sides of an equation. You get what's called an extraneous solution. And that can sometimes happen when you're working with radical equations like we're working with in section 9.5. So when you're done with these problems, you always have to check your answer. It's just part of the work here. So let's keep an eye on this when we start working with problems from this section like this one. 2a minus square root of 2a minus 3 plus 3 equals a. If this was a face-to-face class or not, I would still tell you to look out for these problems because there's a couple things I like about them. Now, to get started, you got to get this root by itself. So I'll subtract 3 from both sides. That gives me the square root of 2a minus 3 equals a minus 3. You could also write negative 3 plus a. That'd be okay too, but I think it works out better to write it like this. To get rid of the radical, I'm going to square both sides of this. And here's one of the things I warn people about. You've got to be careful squaring the right-hand side. You can't just do a squared plus 9 or a squared minus 9. You can't square just each of these terms. You have to multiply it by itself. So that's going to be a minus 3 times a minus 3. You got to FOIL it out. I'm just going to bring this down. That's not going to change to a minus 3. First squared, a times a, or first terms, I should say, a times a is a squared. Outside, inside, and last. Negative 3 times negative 3 is a positive 9. Now there's like terms that I can combine here. Negative 3 and negative 3 gives me negative 6. So a squared minus 6a plus 9. So I'll pause here. Are we okay with squaring out that right-hand side? Clearly, you don't get a squared plus 9. All right, there's a little bit more to it than that. Now, kind of like our previous example here, you want to get 0 on one side. So I'll do that. I want to put 0 on this side. That means I need to move the 3 over here. Excuse me, the negative 3 over here and the 2a over here as well. So I'll subtract 2a and add 3 to both sides.
I have a question.
Yeah, please.
Just making sure, are you subtracting it from the left side just because there's less on that side?
Yeah, well, not only is there less on that side, but there's a squared term on the right-hand side. And I want to factor whatever I get on the right-hand side because it has that squared term. So,
Okay.
yeah. Thank you for the question. Now, on the left-hand side, I'm left with 0. How about on the right-hand side? What do I get when I combine these terms? A squared
Minus 8a plus 12.
minus 8a plus 12. Perfect. Now, this will factor. That's the stuff we did in chapter 8. This is the nice case of factorization, so I'll put an A here and an A here. Both of these signs have to be the same because this is positive. You're either going to multiply 2 negatives or 2 positives. What's it going to be in this case, 2 negatives or 2 positives?
2 negatives. It would be a minus 2 and a minus 6.
Perfect. Thank you, Dorina. Now, just like before, I've got something times something else equals 0. One of those somethings has to be 0. Now, some of you can probably just look at this and read it off. That's great. A equals 2. Others maybe want to take this step and say, okay, well, this could be 0. Oh, and that means A equals 6. So there we go. We got 2 possible solutions. But are they actual solutions? Well, we got to check. And we'll check A equals 6. When we check A equals 6, that goes back up here into your original equation, not into one of these other equations, into the very first one up there. So let me write that like this. And wherever there's a parenthesis, that is wherever there was an A, I'm now going to put in a 6. And maybe from the videos before this, you saw that I like to put a little question mark there because I don't know if this is true or not yet. 12 minus 3 gives me the square root of 9. Square root of 9 plus 3 is really 6 plus 3, which is 6 equals 6. So that one works as a solution. Do I have to try this one, or if one worked, they should both work?
You have to try both of them.
Yes, thanks, Grace. So we got to try both of them. And I'll do the same thing here that I did just a moment ago. And I'll write the problem with the parentheses, and then this time instead of A equals 6, I've got A equals 2. That gives me the square root of 1 plus 3. Does that equal 2? Does 4 equal 2? I don't think so. What was the fancy name for that kind of a solution?
An extraneous.
Nice, extraneous. Excellent, excellent. So that one doesn't work. On a face-to-face exam, I would just have you strike it through like that, just to let me know that that's extraneous. I didn't make people spell extraneous. Spelling was never my strong suit. So, yeah, but there you go. Now, on WebAssign, Let me see if I can't find this example, what you're going to see. Right up here. So you're gonna have to put in your answers in order, which I find annoying. They say the smaller answer than the larger answer, but whatever. And then you have to tell whether the solution is extraneous or not. So that's what to expect on WebAssign. Any comments or kind of wrap up with this one?
Is it possible to have two extraneous solutions if you have two potential solutions?
Yes, great question. You could have, so you could have both of these be extraneous. You could have one be extraneous or none be extraneous. Actually, both work. So it's just going to kind of depend on the problem. But yes, it's a great question. You could have two extraneous solutions. While we're on the subject of that last one, there was a problem that came up with one of the questions for a student in my morning class. And let me just kind of show you sort of the happy ending of that problem. It was something like this: square root of y plus 9 equals 3 minus y. And, you know, one of my students wrote it like this instead of the way I wrote it. They wrote negative y plus 3. And you can do that. You just got to be a little bit more careful when you square this out. So it'll be y plus 9 equals negative y plus 3 times negative y plus 3. Nothing wrong with doing it this way. Y plus 9 equals negative y times negative y is y squared. And then you'll get a minus 3y and another minus 3y, and finally a plus 9. Now, the part that I want to get to is coming up in just a second here. Let me combine the like terms here. So negative 3 and negative 3 gives me negative 6 as before. This time I'm going to subtract y from both sides and also subtract a 9 from both sides. So I get 0 equals y squared minus 7y. And a lot of people get really stuck here. They're like, oh my God, how do you factor that? And the thing you got to remember is, what's our number one trick in trying to factor something? The first thing you always look for. Does anyone remember?
GCF.
GCF. And there you go. So what you would end up with is two possible solutions. Either this equals 0 or this equals 0. And then you'd have to check them both in the original problem. So just kind of a heads up here. Like I said, it's this last part here. People get in a groove. They're dealing with quadratic equations. They want to factor it as trinomials. And this one's just a GCF. So, okay. A couple more here to finish things up. Let's see. I'll try and not use up all my scrap paper in one go. Scrap paper is getting tougher and tougher for me to come by. Let's try this one. Square root of 10 minus 2x equals 6 times the square root of x minus 5. Let me drop that one down. Kind of like a lot of these, we're going to start by squaring both sides. By the way, we're lucky because each of the radicals is more or less isolated. We didn't have to move one term or another. Sometimes you'll have more than one radical and you have to square things like a couple times to get rid of all the radicals. Those are problems that are more challenging, but kindly I left them off of your homework. When I square the left-hand side, what do I get?
10 minus 2x.
Excellent, thank you. On the right-hand side, I gotta be a little bit more careful. I get the 6 squared and I get this squared. Now 6 squared is 36. What do I get when I square this part right here?
X minus 5.
Thank you so much. X minus 5. There you go. So like I said, the tricky part is realizing you have to square this and you get a 36, but when you square this, it just gets rid of the root. You're left with X minus 5. Let's distribute that 36 to both of these. If you remember back to the start of the course, I had something I called Jeff's rule, and it was for deciding where do you want to put the variable, the left-hand side or the right-hand side. But because 36 is bigger than -2, I'm going to put the variable on the right-hand side. So I'll add 2x to both sides. So it gives me 10 equals 38x minus 180. And if I add 180 to both sides, I end up with 190 equals 38x. Okay, 190 equals 38x. Divide both sides by 38, and we end up with x equals 5. Am I done? We're all good with that? Yes?
No, you gotta check it.
Ah, well done. You got to check it. Thank you, Laurel. So if we put it back into the original problem, it's going to look like this. Square root of 10 minus 2 times our answer. Does that equal 6 times the square root of our answer minus 5? So if I put in a 5 here and a 5 here, I get the square root of 0 equals 6 times the square root of 0, which is the ever fun 0 equals 0. What do you think? Does 0 equal 0?
Yeah.
Oh, yeah. It works. So that is a solution. Nice. And how are we looking on that one? We're good there? Let's try one last one like this. And a little bit of a twist, a little bit different. 21 equals the cube root of p over 0.02. This is a formula that relates, excuse me, I don't want to put, yeah, let's see. I'm kind of getting ahead of myself. Let me show you the problem here first. Power generated by a certain windmill is related to the velocity of the wind by the formula. V equals cube root of P over 0.02. P is power in watts and V is velocity of the wind in mph. Find how much power the windmill is generating when the wind is 21 miles per hour. Okay, so what they're doing here is they're giving you a nice little radical equation, but you've got to take and substitute in something. You got to substitute in that 21 into the problem. Where does that 21 go in for? V or P?
B.
V.
Yeah, that's the velocity. Good. So we'll plug that in there. And now we get this. So that's kind of like, I'd forgotten the preview of this equation. How am I going to get rid of a cube root? Any suggestions?
Cube both sides.
Cube both sides. Thank you. So if I cube both sides, on the left side, that's like 9261. Get that off your calculator. On the right-hand side, these cancel each other out. P over 0.02. Almost done. What do I got to do to get rid of this? What's the opposite of dividing by 0.02?
Multiply by 0.02.
Perfect. Multiply by 0.02. So 0.02 over 1 The only reason I put it over 1 is because I want to help you see that these cancel. So those cancel, leaves me with P, 0.02 times 9261, 185.22. And the units there would be in watts. Hey. You can check it with your calculator that actually works. Let me, let's see, do I have, I'll take an extra minute, do it on my software calculator rather than my real calculator, because you can see the keystrokes that I use that way. But it's not a bad idea to double check your answers in any case. With radical equations, it's no longer a good idea, it's you have to. Now this one I'm sure we'll check, but so let me just clear everything out. To find the cube root, let's go to the math key. Fourth number down is a cube root, so I'll just type the 4. And you know what? It's got my calculator's in the wrong mode here. There. So let me clear out my key history and start again on this one. Math, and then 4. I want the cube root of my answer divided by 0.002. So my answer was 185.22 divided by 0.02. And that cube root should be 21. Ta-da! So it works. All right, so that one checked. Are we good here? All right, I'll stop here and I'll put you in some groups so you can work on things.